This is lesson 46, and it is segment measures. And this is page 98 and 99. And I think I probably numbered my pages wrong on the last few lessons. I went back and fixed those. Lesson 44 was page 94. Lesson 45 was page 96. And then lesson 46 is page 98. Okay. I do not have post-its for these. I will not have post-its for these. So you may want to stop at this point and draw this picture and then watch it. And then you may want to draw the others. There's several pictures. They're pretty easy to draw, but you can pause at any time and draw the pictures. All I used was a bottle cap and some kind of straight edge. I happen to have a ruler at home, but you can use anything that's stiff enough for a straight edge. So, segment measures. This kind of goes along with that lesson on tangents, which was lesson 41 when we talked about the measures of the segments, not the angle measures. And that's what we're going to look at here. So first, when you have two chords, remember chords go across a circle. They can be a diameter, but they don't have to be. You're going to see that it's proportionally, and we're actually going on and doing the cross multiplication. So if you've got a segment, a chord from C to D, then we're going to take the two parts of it. We're going to say the measure of CE, that's why we don't put a bar over it, times the measure of ED is equal to the two pieces of the chord AB. So we've got AE times EB. And in this case, I'm just going to label this one and use it since the arithmetic is pretty easy. So in this one, we're going to let me find my example. We're going to let CE measure 7. I tried to kind of make them to scale. We're going to let ED measure 16. We're going to let AE be 14. And we're going to let EB be the one we don't know. So you just take your chord and take the two pieces. So we've got 7 times 16 equals 14 times x. So we have 112 is equal to 14x, divide by 14, and we get x is equal to 8. Okay, that's pretty straightforward. Now we've got two secants. I'm going to give you the formula, and then we're going to do 3 examples, because these can get a little messy in the algebra part. The arithmetic's pretty easy, but the algebra can get a little bit messy. So 2 secants. Remember, secants are extended chords that go through the circle. And in this case, these two intersect out here at point F. Now, I'm going to write it, but we're not going to use that picture because it's a little more confusing. Once you get it, it's pretty easy. It's the measure of the whole secant. Let's see, let's write it like this. Times the outside part of the secant. Actually, I think I wrote exterior. That's a little bit shorter. The exterior part equals the whole secant times the exterior part. Okay, so in this picture, this whole secant is from H to F, and then the outside part of it, part outside the circle, is GF. And then you have to take the whole secant, which is JF, and multiply it by the part that's outside, which is IF. So let's try one. This is a very basic one. We're going to let this piece out here be 7, and this piece be 11, and this little outside piece be 6, and this piece be our x. Now, if it doesn't have like an arrow across it, then it means just that part. You know, if they had all of this as x, then that would be your unknown. But in this case, it's just the inside part. And I'm thinking that's the way your problems are going to be set up. So let's use the top secant first. The whole secant is this piece plus this, which is 18. And the outside part of that is 7. And then the whole secant, which we don't know part of it, we can say it's this plus this, like we did up here. But I can say x plus 6 or 6 plus x. I'm actually going to put 6 plus x. It is commutative. Now, I scooted it over just a little bit because the outside part is my 6. Now, I could have put it over here. You can just still distribute from the back end, but we usually like to distribute from the front. So we have 126 is equal to 36 plus 6x. Subtract 36. You have 90 equals 6x. Divide by 6, and you get x is equal to 15. Okay. Let's do the exterior part is 3. The inside part is x minus 5. The exterior part is 4. And the interior part is x minus 8. So we've got the whole. Now we need to look at this. We need to be really careful with this one because we've got the whole secant, which is this plus this. And then you've got the outside part, which is 3. That's pretty easy. So I'm going to do the outside part first, and then I'm going to put my whole secant here. And then the outside part is 4, and then we'll talk about the inside, because look what happens when you do, where do we want to do that? Let's go up here. And we add 3 plus x minus 5. And when I group my like terms together, I have x plus 3 minus 5. And I didn't have to regroup that. You can just put your two like terms together because you got x and then a positive 3 and a negative 5 is negative 2. So all of this adds to x minus 2. You just have to be careful with your signs. So the same thing here. Can you see this down here? Let me scoot it over. Okay, so we've got the outside part, which is 4, plus the x minus 8. So we have our x, and then we have our 4 plus our negative 8, which is negative 4, and that's this side. So you just have to be careful as you're doing the whole thing. You just have to be careful when there's binomials, when there's two things in here. Okay, let's distribute. We've got 3x minus 6 equals 4x minus 16. I'm going to move the 3x. That looks easier. And those are gone. I have negative 6 equals 4x minus 3x is 1x, or just x minus 16. Add the 16. And I get 10 equals x. Okay. And I guess I don't need this one at the top. I was thinking I had another example, but I don't see it. So we'll just skip that for right now. And then we have what's called a tangent and a secant. So you have, now we didn't do a tangent and a tangent because we found out in that lesson, I think we said 41, where if you have two tangents, let's see where that was. Yeah, right here. If you have two tangents, they're the same length. So that one is not going to be one in the list. It's just a tangent and a secant in this case. Now you're going to treat the secant just like you did in the last example. You're going to take the whole secant times the outside part, exterior part, equals, now with a tangent you only have one piece, so you're going to actually just take the tangent, and I think I wrote whole tangent, and to have something else to multiply it by, you're just going to multiply it by itself. That light causes that too. I don't know why it does that. Let me try turning that off and see if that makes a difference. Oh, it does. Okay, so the whole tangent, whole secant is from O to K. The outside part is MK. Now, the whole tangent is LK times itself. Or, if you want to write it LK squared, you can do that. And I usually put that in parentheses. That just comes from my Algebra 2 teaching. So, let's try one. Let's do, let's see. Let's let our tangent be 30. Let's let our inside part of our secant be x. And let's let our outside part be 18. So I'm going to go back up here, and the whole secant is this part. So I'm going to do it first. Didn't matter. You can do either side first, but I just thought I'd do what I had up here. So the whole secant would be 18 plus x, or x plus 18, whichever way you want to say it. And we're going to multiply it by the outside part. And then the tangent is 30. And you can say 30 times 30, or you can just do 30 squared. So when you distribute, you get 324 plus 18x is equal to 900. Subtract 324. you get 18x is equal to 576. And when you divide by 18, you get x equals 32.